Hi everyone, this is only the third attempt at this. I keep screwing it up, so here goes. I'll try it again. Let's say you got yourself a line, and you want to graph it. You know that's the y-intercept, so you go down to 3, and you put a mark. Then you know your slope is 2, so you go up 2 and over 1, and there's your line. Now what I want to work with you on is why is this the y-intercept? If I look at the full coordinate, instead of just telling me the y-intercept is -3, you'll notice the coordinate is 0, -3. And that's an x and a y. Okay? So, when you have a y-intercept, x is 0. So to find the y-intercept, you let x equals 0 and solve for y. So here goes. Let x be 0. So I'm going to let both of these x's be 0. So that's 2 times 0 squared plus 0 minus 6. Well, that's just -6. So your y-intercept is -6. Okay? So I'm going to let x be 0 here. So that's 0. So I get y is equal to 1 over -2 plus 5. So that's -1/2 plus 5 is 4.5. Your y-intercept is 4.5. Let x be 0. -1/2. It's that easy, you guys. You're just letting x be 0. X is 0, so it's gone. So that's 1 over -2 squared. Whoops. I thought it was a plus. It's -4. So that's 1/4 minus 4 is -3 3/4. So you tell me your y-intercept is -3 3/4. Okay? Because in a bit you're going to tell me the x-intercept, so I need you to delineate, distinguish between the x and y-intercepts by labeling them. Okay? X is 0, so that would be 1/4. X is 0. What's the absolute value of 3? 3 minus 2 is 1. Your y-intercept is 1. Let x be 0. What's the absolute value of -2 plus 3? So that'd be 2 plus 3, which is 5. Your y-intercept is 5. Let x be 0. That'd be negative square root of 5 plus 3. There's nothing to do with it, so that's your y-intercept. There, it can't be simplified any further. Now this, if x is 0, you get negative square root of -5 minus 3. Doesn't that involve I? Let's check out the graph quick. So if I graph this, you're starting at 5, -3. 5 over, 3 down. And the leading coefficient is negative. The value of a is negative, so it's the lower half of a sideways parabola. Tell me about the y-intercept. Does it cross the y-axis? No. So that's what happens when you're solving for a y-intercept and you get an imaginary number. Don't tell me -I√5 minus 3, which is what that would simplify to. Nope. Tell me there is none. There is no y-intercept. It doesn't exist. Okay? Now, I'm going to go back up. Well, I guess we'll do this. Let's go back to that line, or one similar to it. Y is equal to 2x minus 3. The y-intercept was -3. The slope was 2. We talked about the y-intercept being 0, -3. Now what I want to talk about is the x-intercept. I don't know what that x value is, but I do know for sure 100%, I'm trying to change the color, 100% that coordinate, it's some x value and the y value is 0. For sure, the y value is 0 because you're sitting on the x-axis. Okay? So how do you find an x-intercept? You let the y value be 0. Add the 3, divide by 2. The x-intercept is 1.5. So how do you find an x-intercept? You let y equal 0 and solve for x. Alright? So, going back to this, I need to let y equal 0. Well, that's just doing the quadratic formula, folks. And y'all know the quadratic formula, so I'm going to leave you to it. It's a 4. Okay? You guys have been doing the quadratic formula for years, so plug and chug. Alright. You let y be 0 to find an x-intercept. The first thing you're going to do is subtract the 5 to the other side. So I got negative 5 is equal to 1 over x minus 2. Now to help you finish that, if you guys had 2/3 is equal to 5 over x, how do you solve it? It's a proportion. You cross multiply. So there's 2x equals 15. Divide by 2, and there it is. It's a proportion. So you cross multiply. Negative 5 times x minus 2 is equal to 1. I can distribute the negative 5 in, so that would be negative 5x plus 10 is equal to 1, heck of a 10. Subtract the 10, negative 5x is negative 9, divide by negative 5, x is 9/5. That's your x-intercept. Okay, so this one, let y be 0. Put it over 1 to help you see it. 0 times x minus 2 is equal to 1. 0 times anything is 0. Oops. 0 times anything is 0. The right side is 1. How often is 0 equal to 1? Never. So there is no solution to this. There is no x-intercept. It doesn't exist. Okay? So go back and let y be 0. Add the 4. 4 is equal to 1 over x minus 2 squared. If you need to, put it over 1 to see it. Cross multiply. That's a heck of a 4. It looks like a 9. 4 is equal to, oops, I'm getting carried away. 4 times x minus 2 squared is equal to 1. You cannot distribute this 4 inside. You cannot distribute the square inside. Remember, you're solving. You want to get rid of this stuff, so you're working up PEMDAS to do it. You get rid of any adding and subtracting first. I can't, because it's in the parenthesis, so you go on to multiplying and dividing. You want the 4 to go away, so divide it out. So then I got x minus 2 squared is equal to 1/4. I want to get rid of the square. Don't expand it and get x squared minus 4x plus 4 equals 1/4. No, that would be a mistake. You didn't get rid of the square, you kept it. Get rid of it by square rooting. So you got x minus 2 equals plus or minus, the square root of 1 is 1, the square root of 4 is 2. Now add the 2 to the other side. 2 plus or minus 1/2. So that's 2.5. 2 minus 1/2 is 1.5. Okay, those are your two x-intercepts. You have 2 of them. Okay, this one, let y be 0. Cross multiply. Again, you get 0 equals 1. No x-intercept. Okay, doesn't exist. Alright? Come on. Alright, let y be 0. Add the 2. 2 is equal to the absolute value of x plus 3. Now, y'all learned to do these set up this way. There's nothing wrong with it being written that way. I'm just trying to jog your memory by writing it this way. You have to set up 2 different equations. X plus 3 is 2, and x plus 3 equals negative 2. Now solve them both. X equals negative 1. X equals negative 5. Those are your 2 answers. You do the same thing here. Subtract the 3. Now, there's a problem with this one. doesn't an absolute value make something positive? Meaning, like, if you had 25, isn't that 25? Or negative 17, isn't that 17? So an absolute value is always positive. How could this absolute value then equal something negative? It can't. There is no x-intercept for this problem. Graphically, you could see it. It starts at 2, 3, 2, 3. A is positive, so it's the upper half. So tell me about the x-intercept. It doesn't have one. Okay? So an absolute value cannot equal something negative. It doesn't work. Okay? Let this be 0. Subtract the 3 from both sides. Negative square root of x plus 5, divide by the negative. 3 is equal to the square root of x plus 5. How do you get rid of a square root? You square both sides. Subtract the 5 and you got it. Okay? Let y be 0. Add the 3. Get rid of this negative out front by dividing it out. And that should stop you and pause you right there. Because a square root can never equal a negative number. If you don't believe me, which I would understand if you didn't, the x value is 5, so 5 over. The y value is negative 3, so 5, negative 3. The a is negative, so it's the lower half of a sideways parabola. There is no x-intercept for this. It doesn't exist. You don't have one. Okay? So, the reason I'm pausing, what did I do wrong on this one? 2 right, 3 up. Why did I say the y-intercept is 5 on that one? 2 right, 3 up. But there isn't a y-intercept. Let me pause this and think about this, why I said that. Hold on. Oh my goodness, you guys. Oh, I guess I didn't have my ginkgo biloba today or something. This isn't a square root graph. What was I thinking? It's an absolute value graph. Oh my goodness. So, let me erase some of this. I'm like embarrassed beyond belief. Okay, you ready? It's a V graph. 2 right, 3 up, and it's in the shape of a V. So of course it has a y-intercept, and the y-intercept would be 5. Oh my goodness. Let's hope the day gets better. Have yourself a great one. Thanks for listening.